All right, guys. Happy Friday. I don't know if it's a Friday for you. It's not a Friday for me, but it feels like a Friday because it's the last lesson of the week. 14.4 Approximating Square Roots. So, what are we doing today? We're approximating square roots and we're classifying real numbers. Sorry to burst you guys' bubble, but not all square roots go in evenly. Square root of 4, great. It's 2. 2 times 2 is 4. Square root of 9, great. 3 times 3 is 9. Square root of 6. There's not two of the same numbers that multiply to 6. 2 times 2 is 4. 3 times 3 is 9. That doesn't work. 2 times 3 is 6, but the 2 and 3 are not the same numbers. So we need to approximate. Yep. And we're also classifying real numbers. So how do you classify real numbers? Let's look at all the different types of numbers. The first type of numbers is a natural number. That's the smallest set of numbers. Natural numbers are 1, 2, 3, 4, 5, on forever. We call those counting numbers because they're numbers you count with on your fingers, on your hand. Can you count the number 0 using a finger? No, that's just a fist. So we're not putting 0 as a natural number. Instead, 0 is considered a whole number. So natural numbers and whole numbers are almost the exact same, except whole numbers include the number 0. That's the only difference. And whole numbers are not fractions, or not decimals, not percents, just the whole number itself. Next are integers. Integers are the exact same as a whole number. It's just the negatives also. So 0, 1, 2, 3, 4, 5, but 0, -1, -2, -3, -4, -5 as well. Next are rational numbers. Rational numbers are all fractions or decimals, but for the decimals, they're only rational if they stop or if they start repeating. If they go on forever and they do not ever repeat, it's not a rational number. For example, pi, 3.1415943260. I don't know, whatever it is. That's not a rational number because it does not terminate, it does not repeat, it doesn't stop, and it never repeats, so it's not a rational number. So then we have irrational numbers. That's a separate thing. So irrational numbers, like I said, are pi, but it's also just a random 7.41473, right? So let's kind of go back. Let's kind of just think about it. Natural numbers are whole numbers. So every natural number is also a whole number. Well, every whole number is also an integer. Every integer is also a rational number, but rational and irrational are separate. So when we go to real numbers are all of these: natural, whole, integer, rational, irrational. Every number you can think of is a real number. What's not a real number? An imaginary number. You will learn that in high school. 5i is an imaginary number because 5i is the square root of -5. Remember I said you can't have a negative in a square root? Well, that's an imaginary number. It's fake, it's not real, but we still use it for graphs. It's really cool. So since that's imaginary, it's not a real number, but all the numbers you guys have ever seen before is a real number unless there's a square root of a negative number. Then it's not real. All right, so classify the real numbers. So 3. 3 is an integer, right? 3 is a whole number. 3 is rational. 3 is natural, right? So it's a natural number, a whole number, an integer, and it's rational. Let's look at b. Well, b is not a natural number. It's not a whole number. It's not an integer because all natural, whole, and integers are all just a plain number. But it is rational, right? So it's just a rational number. C. It's not natural, whole, or an integer because it's not the whole number itself, right? It's a fraction. So this is just rational. And then D, square root of 17, is that going evenly? No. So there's no two numbers that multiply to 17. So since that's not, that will be a decimal. It'll be 4.1 something, 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 right? But it never repeats. So it's irrational. Hope you guys kind of understand those. Simple 2, estimate the square roots to the nearest integer and to the nearest tenth. So square root of 17. Now that's in between, that's going to be in between, let's see, square root of 16 and square root of 25, right? That's the way I look at it. Think of square root of 17 in between square root of 16 and in between square root of 25. So I'm going to put square root here. Let me minus this thing out real quick. So take this out. So that's going to be in between square root of 16 and square root of 25, right? Square root of 17. So square root of 16 is 4. Square root of 25 is 5. So it's in between 4 and 5. But is it closer to 4 or is it closer to 5? Closer to 4, right? Because 17 is really close to 16. So if we estimate it to the nearest integer, we're going to get 4. But to the nearest tenth, it's not going to be exact. That's okay. So we're going to get about 4.1, 4.2 maybe. So we're going to put 4.1. So let's see, what does the next slide say? 4, and it's 4.1. Perfect. So now let's do square root of 23. Well, that's between the square root of 16 and the square root of 25, right? So since that's in between the square root of 16 square root of 25, it's between 4 and 5. But 23 is closer to 25 this time. So that means if we estimate it to the nearest integer, we would get 5. But it's not quite 5. It's a little bit less because it's square root of 23. So therefore, we're going to get 4.7, 4.8, right? So we get 4.8. Yep. Now, negative square root of 80. That's really close to the square root of 81. The square root of 81 is 9. 9 times 9 is 81. So it's not quite 9. So if we did the nearest integer, we're going to put 9. But we're going to put negative 9 because the negative's on the outside. But it's probably more like 7.9. Or no, 8.9. Sorry, it's more like 8.99, but which is really close to 9. So we're going to get negative 9 and negative 8.9. And then the last one, 102, that's a little more than 100. So square root of 100 is 10. So that's going to estimate to about 10, but it's probably more like 10.1 or 10.2 because it's barely after 100. So it's negative 10 and negative 10.1. You guys can use a calculator for this part. Plug 102 into the calculator, take the square root, and you'll get 10.1, blah, 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 blah. So it's 10.1. You can estimate it. But notice, I didn't use a calculator at all. I'm not using a calculator. I'm using my iPad right here, which is the same thing you guys are looking at in my brain. I'm guessing which one it's closer to. 102 is really close to 100, which is square root of 100 is 10. So I know it's really close to 10. If it was like 110, it'd be about 10.5. But it's not. It's 102, so it's really close to 100, which is 10. Classify these real numbers now. 8. So is 8 a counting number? Yep. Is it a whole number? Yep, it's a whole. Is it an integer? Yep. Which means it's going to be rational, right? So it's a natural number, a whole number, an integer, and a rational. Square root of 21 doesn't go in evenly, so it's irrational. Now estimate the square root to the nearest integer and tenth. So we're doing this again. So A, square root of 68. That's close to the square root of 64. Well, square root of 64 is 8. So it's a little more than 8, right? Since it's a little bit more than 8, we can do 8.2 maybe, 8.3, because it's in between square root of 64 and the square root of 81, because that's in between 8 and 9. So it's a lot, 68 is a lot closer than 64 than it is to 81. So I'm going to guess about 8.2, 8.3. And look, if you did the math, you would get 8 and 8.2. 120, that's so close to 121. 11 times 11 is 121. So it's not quite 121. So it's about 10.9 because it's not quite 11. So it's 10.9. But 10.9 rounds up to 11. So the whole number, the integer, would be negative 11. But then for B, it'd be negative 10.9. That makes sense. That's all. That's all we're doing today, guys. So your homework is 2 through 24 evens estimating. I'll allow you guys to use a calculator for it. So that's fine. But it's on big ideas. So congratulations for making it through the week. If you have any questions, let me know. Otherwise, you guys have a great rest of your week.